Hi, everyone, and welcome to the 2018 CodeTalk series. The CodeTalk series is co-sponsored by ODTUG and IOUG and provided by Oracle Developer Advocates. Today's webinar is Common Database Development Disasters, presented by Connor McDonald of Oracle Corporation. If you have any questions during the webinar, please type them into the question box and they'll be answered during the Q&A period at the end of the presentation. Today's presentation will be recorded and available to everyone through the CodeTalk page of the ODTUG website. So welcome, Connor, and thank you for being here today.
Thank you very much. Hopefully you can all see and hear me fine. Shouldn't be a problem. I'm the little guy in the top right corner of your screen, and I've got some bio information that we'll go on to. In fact, I'll stop sharing the screen for a second if I can work out how to do that. Oh. And maybe show my webcam. Let's see if I can make that full screen. Maybe not. Looks like the webcam stays small. Not to worry. Okay, let's go again. Okay, now I've got to make sure my screen comes up again. Let's try that. There we go. So welcome all along. For me, it's 9 p.m. in Perth. So for some of you, it's probably your early risers, perhaps in the US, and hopefully for those who are in Europe or in Asia, it's the middle of your day. But for me, it's the evening. So the most important for me is to make sure you don't see my gin and tonic in the webcam shot at any time during the presentation. But yeah, so it's after dinner for me, but it's always a pleasure to help out and do webinars for the user community. So a bit of stuff about me. This is how you follow me on Twitter, at Connor_MC_D. I have a blog, connormcdonald.com. I also have got into doing YouTube videos now, and that's a shorthand link to my YouTube channel. I got into that because I realized that recently my sync got blocked, and when I was looking for ideas on how to fix it, the first thing I stumbled across was a really useful how-to video on YouTube on how to do it. So I realized that YouTube is becoming a go-to place for handy instructional content, and I figured, why not do the same with Oracle? And for some people in the world, their particular social media favorite tool is Facebook, so you can get to me on Facebook as well. Feel free to reach out there, or through the Oracle database page on Facebook. Obviously, perhaps given the events of the last couple of days, people are steering clear of Facebook, but if you're not, that's how to get in touch with me. Most people know me from AskTom.Oracle.com. Tom Cart retired from Oracle in 2015, and for the last few years, myself and a couple others, Chris Saxon, Maria Colgan, we've been resurrecting the Ask Tom website, and hopefully you've all been involving yourself in the new Ask Tom Office Hours program, which actually lets you have direct contact with product managers within inside Oracle organization. We've already had 20 already in the last month, and literally it's a great way. We turn over an hour of our week to you guys to ask us any questions you want. So please get involved in that. We love having this interaction as opposed to, for example, just sending you slides that you can look at, etc. So today's talk is pretty simple. Database disasters. Now, why would I talk about disasters? Well, probably a better title is perhaps this: really, really silly things that developers do to their databases. And don't get me wrong, I'm both developer and DBA. I could just as easily do a talk on really silly things that DBAs have done to their databases. But let's face it, we're ODTUG, we're the developer community, so I thought we'd focus on development mistakes today. Now, why would I do about this? And if you'll bear with me, I'll have a slight moment on the soapbox just to talk about why I think it's important to talk about failure. Failure is actually, I think, more important than success, because if you go to any website, and don't get me wrong, Oracle's included, go to any company's website, you're going to get customer reference stories. And all those reference stories are obviously very carefully handpicked to be, this is exactly how things went perfectly right using our particular piece of software. Now that's awesome, but what we'd really want to know is, what are the pitfalls, what are the risks, what are the pain points that you might suffer? That's much more valuable, I think, to the community than just putting people up on a pedestal and saying, look how awesome we were and how we survived and how we were successful. In particular, this is the risk that happens when people aren't prepared to share failure. Here I have on the left-hand side your typical, for example, company hierarchy. And these are the kind of things that happen in these hierarchies sometimes. The developer says, I've deployed something, it's got a fatal, catastrophic bug, it's in production, And I phone the DBA and I say, look, I've totally hosed the data. It's absolutely destroyed. The DBA then reports to his team lead and says, oh my God, all the data is corrupt. And this is the problem with organizational hierarchies. No one likes reporting bad news up the chain. So the team lead says to his project manager, you know, we've got a bit of data corruption, we might need to handle it. And the project manager says to his director, yeah, we've got some small issues with data quality. And then the director says, well, we're moving forward with some data challenges because no one wants to report up the line that things are catastrophically bad. The CIO rephrases that as we're maximizing some opportunities in the data space. And when the CEO is talking to the board, he's saying everything is just perfect. And these are the kind of problems you have when failure becomes something that you hide, that you're scared of. So that's why I thought we'd talk about failure today, so we can embrace our failures and embrace our mistakes. And at the same time, we'll learn about how to avoid doing them again. The key thing here is failure does not equal negligence. You know, we're not sitting here trying to basically say, well, people are stupid. We're saying that failure is one of those things where we maybe are just ignorant of the technology or don't understand it, or we're coming to grips with new technology. And that's the key thing. If we learn from failure, we improve. Now, disasters really come about poor decision making. So we're going to walk through some of those things today to see how poor decision making came up with these errors. And in particular, when we talk about decision making, the reason I wanted to do this talk today was your role as a developer is changing in the IT workspace. You used to have what I would call a task-focused role. Someone would say, we're employing you as a Java developer, you write Java. You're a PL/SQL developer, you write PL/SQL. That's changed. Nowadays, you're deemed the expert in all things IT. You go into a company and they'll say, okay, you'll be coding, but you'll be responsible for coming up with a source code control system, some frameworks, some quality control, unit testing, ability to turn those unit tests into integration tests. All these things are now falling into the developer's plates. And you'll see this is probably the more glitchy, hypey, cliched version of that, which is DevOps. That is, you're responsible for so much more in the application development lifecycle now. The reason it's important to be able to talk about mistakes is because the responsibility now for so much stuff in the application lifecycle lies with us as developers. We're no longer just write the code, toss it over the fence, someone else is going to look after testing it, deploying it, etc. We're responsible now for the entire swag of things. And one caveat I will say is it's very easy to turn these kind of talks into like a lynch mob mentality where we just sit there and throw out names and companies and say, look how silly they were, etc. I'm going to show some really silly things that people have done, but we'll keep it anonymous. And please keep in the back of your mind, the whole intent today is about learning from mistakes as opposed to sort of snickering away and laughing at people at the silly things they've done. But let's set the scene with probably the worst piece of coding I've ever seen when it comes to working with an Oracle database. Now, there's a lot of code here on the screen, and so please be aware, we don't have to digest the entire lot of it. This is what we're going to do. So the first part of the code is we're going to build up a list of characters that are all the ASCII characters except those 0 to 9. So A, B, C, D up to Z, uppercase, A through Z, lowercase, etc. Everything except 0 to 9. Then we're going to iterate for the length of that list, and we're going to, if there's 244 characters, which there are, except the number 0 to 9, we're going to go through character 1, 2, 3, all the way up to 244, each time doing a select substring 1 to 244 from dual. So a select from dual to get the ith character. And then with our incoming parameter called ptext, we're going to walk along that text and do a select in string from dual. If a character is found, we return 1, otherwise we return 0. Now, what does all that gobbledygook mean? Okay, I'm going to try demonstrate that hopefully now with the webcam, but I'm hoping the webcam can come to full screen. I'm not sure how I'm going to do that. Karen, if you're there, can you assist me on how I do that?
I am here. And what is it that you're trying to do?
I want to make the webcam full screen, please.
I don't know that you can do that from there. Yeah, I can't make it bigger either.
Oh, well, that's a bit of a pain, isn't it?
Let me see. Oh, wait a minute. You know what? I just pressed the full screen button and I see it full screen now.
Okay, so if I do that, Okay, so if you're an attendee, please press the full screen button on the webinar, on the webcam. Hopefully you can see it's full screen for me, but obviously that doesn't mean a great deal for you.
Yeah, I am looking at it full screen.
Excellent. So hopefully everyone can see on their screen a piece of paper with that piece of code written out in hand. And I thought we'd go through how this routine would actually work. We have our list along here, ABC, all the way through to the end of the quote. What we will do is the first thing we do is the first character, to get the A out, we do select substring 1 and get the A out. And then what we do is say, okay, I've done a call to string check for the 178. I'm going to say, is the character A in 178? If it is, right, I return 1, otherwise I return 0. Then I move on to the next character. Number 2, get the B out. Then I put a B in here. Then I do select in string B of 178 from dual. And then I get the next one out. Character 3, in string C, and so on for all 244 characters. So hopefully that bit of pictorial helps explain exactly what that piece of code was doing. So let's kill the webcam off and go back to here. The question is, what is all that for? How is that useful? Let me change my webcam back to me so people can see my terrible face. What is all that for? Well, when we actually run it, it probably leans a bit more idea as to what's going on. If I call the routine with the value 123, it returns 0. If I call the routine with 12C3, it returns 1. And in fact, it's actually an is numeric function. Pass in a string, if it's a number, return 0, otherwise return 1. Every execution of that routine did 244 select substrings from dual and 244 select in strings from dual. It was used everywhere in this site. In fact, they had all these external systems that would come through. I'm sorry, oh, people can't see my screen, can they? Sorry, can people not see my screen? My apologies. That's better. Sorry, I should go back up.
You got it.
My apologies. I could see people looking blindly at me. So as I said, 244 substrings from dual, 234 in strings from dual for every single execution, and it was used everywhere in this application. Every single external system that passed in information, we had, if there was any sense that they needed some numeric data that they were passing, we would call this routine before it got passed into our system. That meant 2,444 logical IOs in version 8.1.7, which this client was, for every execution of that routine, because there are 5 logical IOs back in Oracle 8.1 to do a select from dual. And in fact, the reason I got called into this client was I said, we got all these performance problems, our CPU is absolutely maxed out. And I used to have a standard SQL query I used to run, select from $SQL where buffer gets greater than 1 million to see what the problems were. That's the most likely cause of a CPU issue. And you can imagine my surprise when my script was broken in the sense that the buffer gets and executions column was so large, it actually came out as hashes in my SQL+. I actually had to change the width of the column to actually show that we were doing, on an average day, 1.6 billion logical IOs because this routine was called so often and did all these select from duals. It absolutely was smoking the server. That's about the worst I've seen. And it seems really strange that why would this be the case? Because Oracle has an isNumber function. Well, it almost has one. And that this is something you probably have seen in many sites, is a really easy way of implementing that same logic would be pass in some text, try convert it to a number. If it converts fine, return 0, otherwise return -1. No logical IO, it's more accurate because the existing string check routine that was written by this person didn't handle things like negative signs or decimal points, etc. And obviously it's far more efficient. And in 12C, you can go even better. You don't have to write your own pure SQL. We actually have some native utilities now. Validate conversion. You can say, take a piece of text, validate it as a number, and return 1 or 0. Similarly, the cast function's been extended such that you can return a default value if you can't cast something to a particular data type. So I can do cast ptext in as number. If I can't cast it to a number, I can return 1 on a conversion error. And in fact, the fact that it's a native function now, I don't even need it in PL SQL. I can just call it directly in PL SQL or in SQL. So 12c has made that whole process that much more simple. So I went back to the developer as I was visiting this site, and I said, why did you write this routine like this? And as a quick sidebar, I will say, always just ask why. Always be inquisitive. It's so easy to go, in fact, this is what I did. I said, which bumbling fool wrote this piece of junk? And that was, don't get me wrong, this is the wrong thing to say, because in particular, it was most embarrassing for me because a little hand goes up in the desk right next to me. And this guy says, yeah, I did. And I felt, quite silly. But just as an aside, it's so important that once you've been working with the technology for a long, long time, it's very easy to get into that habit of to be very critical of people that ask what you would think are beginner or silly questions. And be aware that we were all in that position at one stage. In fact, I've put a link here, tinyurl.com/b-nicer. It's a great website post here where it talks about some guidelines about how to guide people through that early stage of their career. And that doesn't necessarily mean they're young. It could be their early stage of their career with a new technology. So making sure that you actually support them and nurture them as opposed to belittle them and humiliate them. And so I fully accept I was totally in the wrong in doing that, but I was younger and sillier in those days. And the developer said to me, I don't really know about two-number. That's why I didn't write a function. I didn't know Oracle had a two-number function. He had come from a SQL Server background. And this is that problem of escalating failure. The project manager said, he didn't want to say that his team was actually inept. He said, oh no, we did it deliberately so it would be cross-platform because we didn't want to rely on the two-number function. And of course, eventually, when we escalated this to the CIO of this product, he said, our other clients are happy, we don't know what you're talking about. So that's the importance of sharing failure, the fact that it's not a bad slant on the organization or the people that are actually writing that code. But it does obviously show the importance of load testing because a single execution of that routine ran fine. In fact, 100 executions of that routine ran fine. But infinity times anything will always cause you problems on your servers. So be aware of that. Now, I know what you're thinking. You're thinking, we would never do anything that's stupid. And it's very easy to become defensive. That's probably the worst routine you've ever seen to actually validate something being a number. And of course, we would never do anything that's stupid. But let's lead to our, that's the introduction complete. What's our first common mistake? And this is what I call hidden costs. Number one, if you don't do select star from dual 2,000 times to validate a number, perhaps you do something like this. It's just a PL SQL routine in which we assign the value user to a variable called X. No, maybe not. Well, let's build it up and see where you might actually get into this kind of position. Here's a table called people. And the specifics aren't really important, but obviously as a common requirement is, as we insert rows, we want to know who inserted that row. So I've got that column on line 6 created by varchar 210, and the default is user. As I log on, I'm going to store the default. And that works fine. You can see I do an insert statement here. I didn't specify created by in the insert statement columns, but when I actually insert the row and I do select created by, you can see I must have been connected as the user called Scott. So that works all fine. And of course, the logical request there is, let's extend that to being what about when the row is modified? Now, if I do add modified by and default user as well, that works fine on an insert. But for example, what about an update? I connect as John, perform an update, and guess what? The default clause only works on insert. It doesn't work on anything else. So we can see how I should have set the modified by to John, but it remains at Scott, which was its initial insert value. How do we solve this? People solve it all the time using database triggers. And here's a very simple example of how those triggers might look. I'm actually covering off both cases here of the insert and the update. So before insert or update, if I'm inserting, I'm going to set new created by. And people often do this because they're worried that just because we have a default statement, someone might explicitly code a null value into the created by column, and that will override it unless you're doing some things on 12c. So they put it into the trigger, and always is the case, we'll do modified by equals user as well. Remember I said this importance of load testing, that a single and even 100 executions might be fine? I put a trace on, and I said, now that I've got that trigger in place, let's do an insert into people just a copy of the rows from DBA objects. So that gives me about 78, almost 80,000 rows being inserted in there. And you can see it took 8.5 seconds on my laptop here, most of which was all CPU. So 8.63 seconds, all of which was CPU. Even though it's 80,000 rows, that strikes me as being pretty slow. Oracle should be able to do better than that. Where's the pain point? It's actually what we call context switching. The trigger fires every time for every single row. And when I look further down in the trace, I see this interesting anomaly. I did a select user from Joule 157,000 times. Now, I didn't code select user from Joule, but unfortunately, whenever you do a variable of something equals user in PL SQL, that is implemented behind the scenes with a select user from Joule. So I put this example here because people are saying we would never do something as silly as select, substring from Joule lots and lots of times, like that 2-number example. But it's amazing how things can sneak up on you. So in this case, every time you do x equals user, we effectively are doing select user from Joule. Now we don't have to use the built-in function of user. I could replace that trigger using a context variable. And in fact, one of the context variables that's given to you by default is user_end, the default context, with session_user. It returns the same value. Now when I run that, you can see the enormous benefit I get. Instead of 8.5 seconds, it runs approximately 16 times faster, half a second to insert the same number of rows. The reason for that is the syscontext call to user environment does not do a select from Joule. So the context switching is dramatically reduced. So be aware of the fact that common mistake number 1 is hidden costs. Just because you don't code select from Joule doesn't mean it might not be happening on your behalf. So that load testing is really important. UID is another example. User is one we just saw. There are some others as well. So whenever you're using some of the provided pseudo functions inside Oracle, I would stress, do some tracing, do some load testing, make sure you're not encountering things like select from Joule. You may want to work around that. Now, while we're talking triggers, let's move on to common mistake number 2, and that is wrong data. Now, here's a controversial statement, just to hopefully keep ourselves going through the webinar. We're just over 20 minutes in. Triggers are possibly corrupting your database. They are a classic way to corrupt your database. And the main problem is that people use triggers for what I call do-it-yourself data integrity. And this is a true story. We had a table called manufacturer. So we have someone who manufactures products, and a child table, as it would make sense, contains the products that were made for that manufacturer or by that manufacturer. Now, a business rule, which makes a lot of sense, is for every single product we produce, it must belong to a particular manufacturer. We must enforce that relationship. And obviously, the most obvious way to do it would be add a primary key to the manufacturer table and then add a foreign key from the product table back to the manufacturer table. At this particular client site, they hadn't done that. And we'll get to why they didn't do that a little later on. So this is how they did it. We could do it using triggers. So every time we insert or update a product, we would take the incoming manufacturer ID and call the new.man ID and query the manufacturer table. Make sure it's already there. And if not, we would abort. So it's exactly what we'd see in a foreign key. Here comes a child row, look up the parent row. If it's not there, something's wrong. And then we have the opposite, which is every time you do a delete on the parent row, let's see if there's any product rows, as in child rows for that particular manufacturer. And if there is, you're not allowed to do it as well. Testing works fine. And here's the king. Let's do some testing. I insert a row into the product table, value 100, and let's assume that's an existing manufacturer. It works fine. I try and insert a row with a manufacturer of value 101. That's not a valid manufacturer, and I get the correct error, manufacturer is not valid. I try to do a delete from the manufacturer table for the particular manufacturer, and it says, I'm sorry, that manufacturer is in use. There are some child records, and that works fine. And then 1 month later, which is when I got the call, basically saying, we think there's a bug in Oracle, we have this problem. They have this issue of the data is no longer valid. They found some products that are mapped to a manufacturer that no longer exist in the manufacturer table. In fact, we did a count and we could see we have 86 manufacturers that actually simply no longer exist. We have products that are now orphaned off, and we have a data corruption. And the question is how? They showed us their testing. Look, the trigger's fine. They always work. They've always been enabled. We've never turned them off. How could this possibly happen? And here's the thing. Do-it-yourself integrity typically is synonymous with absolutely no integrity at all. An Oracle feature that has been there since Oracle 4, which is 25 years ago, is consistent non-blocking read. Or you may have heard the term readers don't block writers and writers don't block readers. And so when we look at a timeline of this application, it's actually fairly simple as to what was going on. They would create a product with, say, manufacturer equals 7. The trigger would fire and say, does manufacturer number 7 exist? Yes, it does. So the insert is allowed. Then someone comes and says, in another session, it says, I'm going to delete manufacturer number 7. They're going to do a query. Are there any products yet for which manufacturing 7 is present? And no, there aren't, because the session underneath the timeline there has not yet committed. So they'll be totally allowed to delete manufacturer number 7. The bottom session commits, the top session commits, and there's our data corruption in a simple timeline. I've done a delete when I shouldn't have been allowed to. And that's the problem. Referential integrity actually seems a really simple thing to do. In terms of verbalizing it to someone, you simply say, before you do X, look up Y. Simple as that. It's actually really complicated. It's a hard thing to get right. There's read consistency issues. You need to work out the right style of blocking and locking to make sure that those data corruptions don't actually occur. Now, I know what you're thinking. Once again, we would never do anything that stupid. It sneaks in everywhere, this kind of stuff. That's the key, right? So even with one table, you can get yourself into trouble. So now I'm going to kill off my slideshow. Now, let's make sure we can actually see. Okay, can everyone see my screen? Hopefully. Yes, some SQL windows are coming up. Cool. So I'm going to run in this screen first. Oh, I'll bring that down there so it's underneath that, a bit lower. There we go. So hopefully that font is large enough. Hopefully you're watching this on full screen. I'm creating a table called employee. It's just got 1,000 rows in it. I'm adding a column to it saying every time I create a row, store the time I created it in a column called row creation. And what I'm going to use this for is to do an audit of every change to the employee table to copy it over to a clone of the employee table. So I'm going to create a table called control, which is the last time I ran my cloning process. Now, what's that cloning process? Let's go over to session number 2. And I'll start off with a table called emp audit, and it's an exact copy of the employee table. So at the moment, the employee table and emp audit table are totally in sync. And I'm going to try to keep them in sync by doing this. I've got this procedure called copy new rows. Every time I run this, I'm going to go look in the employee table for any rows created since the last time I ran this routine. So it's effectively picking up all the deltas since the last time I ran this routine called copy new rows. Copy them into the employee audit table, and then I update my control table to say, yep, I've just run it, and I commit the change. That seems fairly simple. So let's see how our tables look at the moment. I'm doing a select everything from the employee audit table minus the emp table, and the reverse, everything from the emp table minus the emp audit table. So I've got both directions there, and I can see I've got no rows selected, which means the tables must be identical. Let's go back to session 1. I insert a row into the employee table. In this case, it's me. I go into a session number 2. Let's run our scheduled update. I run copy new rows. It ran fine. I double check, are all the rows here identical? There's no discrepancies between the two tables. Everything still seems fine. Let's go back to session 1. And now I commit. I go over here. Now I've got a problem. This row is in the employee table and is not in the employee audit table. Now you might be thinking, I'll just run the copy deltas routine again. But look at the data here. This row was created at 21:30 and 26 seconds. The last time I ran the routine was after that. The next time I run this routine, I'm going to be looking for all the rows after 9:30 and 34 seconds. This row will never ever be picked up again. So even with one single table, the moment you're starting to do processes that read from that table and you're assuming some data consistency, you need to be very careful about outstanding transactions. Okay, let's fire up the screen slideshow again. Hopefully we can all see that. So as I said, even with one table, you can get into trouble with data integrity. This is one of my favorite quotes from that particular client site. They said to me, the project manager said, okay, you found all these problems. What percentage data integrity do you have? Now for me, I would call it a Boolean. You either have it or you don't. And obviously these people did not. So concurrency testing is vital. And this is awesome for anyone who's a developer on the call. This is super great for us because if you've ever wanted the justification to have a second PC or a second monitor on your desk, you are set. You simply say, I need it for my concurrency testing. There are so many ways that you can get into trouble when it comes to dealing with things like data integrity in working with triggers and things like that. Now you might be thinking, oh great, thanks for telling me how my data is now screwed. How do I get around it? Let's look at how you can look at retrofitting some solutions to that. I will admit, it's like pushing the proverbial uphill sometimes, right? None of these solutions are perfect, but if you're in a state where you're now deep in a quagmire of data corruption, this is some of the things you might want to consider. First option you might want to do is obviously apply some standard constraints. Now, the first thing is you'll need to fix the existing data, and that's quite hard. If you've got, for example, products without a manufacturer, you need to work out what the correct manufacturers were. That's no longer present in your database. You might have some pseudo relationships, and that's a really awkward one. Sometimes people are implementing data integrity with triggers because they haven't actually got a genuine database design. The foreign key they're using to look back to a parent table doesn't actually have a unique key. They're very tough to fix. There's also sequencing issues when you actually just want to apply standard constraints. What if the way the system is running is they're inserting child records first, then the parent? So if you're trying to put on standard constraints, you'll have problems there. You might want to consider using deferred constraints. Some other resolutions to look at is trying to reduce the probability of it happening. If you have a long period of time between the DML occurring and the commit occurring, that's when you're most exposed to these kind of things. So you might want to go through your code and look and see if you can shrink that window so the DML and the commits are very tightly bound together. Don't get me wrong, that might involve spending a lot of money changing code for what is still ultimately effectively a prayer-based system. You're just hoping that it's not going to hurt. You can't actually make that guarantee. Other resolutions you can look at is locking the parent row. That solves the problem, for example, in the manufacturer and the product table. Lock the manufacturer before you do anything with the parent table. That obviously causes serialization and might cause you some issues in your application. It might not be expecting that. And obviously there's actually complexity involved with doing that, because how do you lock a parent if it doesn't yet exist? If I want to, for example, insert a parent, then insert a manufacturer, then insert a product, right? How do I make sure no one else inserts a manufacturer at the same time or deletes it? It doesn't actually exist yet. So you might want to look at things like DBMS lock to handle the complexities. They're hard to do. The fourth option you might want to consider is adding to the data model. And that's what we did with this particular client. It solved some of those pseudo integrity problems. Going back to these clients who had their manufacturers and their products, I asked them, I said, you've got a manufacturer ID on the product table. Why didn't you just use a normal foreign key? And the answer was this: at some stage in the application's past, they had changed the primary key in the manufacturer table to include a sequence number so they could store manufacturer historical records on the same table. They hadn't rolled that through to the product ID table, and so the true foreign key primary key relationship was broken. They couldn't actually apply it, and that's when they went down the trigger route. You can't apply that foreign key. What we did to try to fix the problem was we said, we'll create you a materialized view which gives you a manufacturer parent which just has the ID as a primary key, and then we'll use standard RI to go back to that. So we added to the data model to try to solve some of these problems. The key thing is avoiding the trap, and this is the biggest thing, right? You get these things what I call stealth integrity rules, which often in a module specification, it doesn't say these two entities have a foreign key relationship. It'll say something like this: when you're creating a product, and then we skip down to the line in green, validate the manufacturer ID, it must exist in the manufacturer table. When you're coding that, it's so easy just to go, before I insert a product, run a query on the manufacturer ID table. Whether it's in a trigger or in your application or anything, it's so easy to miss the fact that that's actually a business referential integrity constraint, not just a coding instruction. I suppose the key message here is, if you're a savvy developer, a smart developer in other database platforms, make sure that you learn up or teach yourself up on the way data consistency works in Oracle as well, and vice versa. Now, while we're talking RI, we're getting on to our next common mistake, and that is what I call deliberately poor performance. Now, RI is not just for RI. Now, that may seem like a strange statement to make, but RI is much more useful than just implementing referential integrity constraints. And in particular, when you use referential integrity constraints, what you are doing is giving the database information to actually do its job. And if you don't give the database that information, if you give the database the silent treatment, you can have problems. In fact, talking to your database actually makes it faster. Now let's look at an example of this. I've got 3 tables. I've got a stores table. It's a logical parent of my customers table, and the customers will each customer will do sales. So I have sales for customers that go back to our customers table, and those customers go to stores. So it's a standard grandparent-parent-child relationship. Here's a query returning basically per product what customers were spent with the amount was greater than 10. The actual specifics doesn't really matter. What's the best way of running it? Should I do a hash outer join, a nested loop? Should I access the stores table first? Should I maybe do a sort merge? This is what the database came up with. You can see the execution plan. We actually started with the customers table, hacked into the stores table via an index, and then went to the sales table with a combination of hash group by and nested loop semi, etc. The question that often is asked of us, let's say that query runs a bit slowly, and that's the execution plan, is can you do better? Maybe we should add some indexes. Maybe we should rewrite the query to something else. Maybe we should use result caching. We'll look at that later on today. Maybe we should use a materialized view. Maybe we should give up and move the whole thing into Hadoop. Let's have a look at what we can do. If you share your knowledge with the DB, the database, things might improve. So let's bring back our window. Just need the one window this time. So I'm going to create a table called stores, create a table called customers, and create a table called sales. So that's the 3 tables we saw. Now let's put in 50 rows into our stores table, 5,000 rows into our customers table, and takes a little bit of a while. We'll put 1 million sales records in, and that's now done. So let's do the normal stuff. We'll put a unique index on the store ID, customer ID, sales ID, etc. Put some indexes on, do a pause. Here's the query we saw in the presentation slideshow. And if we look at the execution plan, it is exactly the same as we saw in the slideshow. In fact, I simply copied and pasted it. So that looks like what the optimizer is doing. And then I posed you the question, can we do better? Well, let's do nothing with the SQL. Let's just do what we know and share that with the database. We know that store ID is a primary key. Cust ID is a primary key of the customers table. Sales ID is a primary key of the sales table. Let's make those columns not null where they should be not null. Let's modify the store ID not null. Let's do some foreign keys because we know the foreign keys should exist. Now let's look at that same query again. Now, what do you think it's going to do? Which table do you think it's going to access first? We might be thinking, I haven't changed any of the indexes. I haven't changed the SQL. No stats have been changed. All I've done is told the database about some of the relationships that exist between the data. Is that good enough to make my SQL run faster? Feel free to throw on the chat line if you want which table you think is going to go first. Let's have a look at what the execution plan is. It doesn't read a single table at all. How awesomely mind-blowing is that? In fact, the only thing it's doing is scanning the index we created at the start, sales IX prod. It didn't even have to touch any of the tables. That is the benefit of adding knowledge about the knowledge that you have about the data onto the database. It can do incredible things in terms of transforming queries and optimizing queries to make them run incredibly quickly. This case is just Amazing. Let's go back to our slideshow. So sharing your knowledge of the DB makes it faster. Now, while we're talking about letting the database know about stuff, that comes to common mistake number 4, which is failure to do pagination properly, and it's probably the most common thing we have to do in our applications. Applications are typically just a window into the data, and often we have to page through that data. Pagination, let's look at an example. Employees by hire date, the most recent first. Now, let's look at this example of a query while I take a sip of my water. Select from the employee table, take the first 5 rows, order by hire date. Or you might be thinking where row number less than 5, it's the same syntax effectively. That is a terrible idea. In fact, it's just plain wrong. Now, I would imagine a lot of people on the call will be well aware of this, that you simply can't do a where clause where row number less than 5 and then apply the order by clause. You'll get 5 records at random and then you'll sort them. So it's no good. It doesn't give you the top employees. The reason I put the example here in is I know what you're thinking. We would never do anything that stupid. This exact question was on Stack Overflow just 2 weeks ago. And the advice given to someone was just do a where row num and an order by. And when I pointed out that that's wrong, they even said, look, there's an order by in there. They're going to get the right number of rows. So just because some of us on the call are probably more experienced, don't ever underestimate the importance of going back to those basic principles. Now, the way we solve it is with an inline view. And most of us have probably seen this. We do the order by first on line 5, wrap the whole thing in an inline view, and then do where row num less than or equal to 5. Or you can do row number, which is an analytic function. You get the same effect. Or you can do fetch first 5 rows only, which is a 12C SQL optimization. It actually translates it into one of the other queries anyway, but all those things work. At which point people say, look, too long, didn't read. I can just do it with my application. Here's my Java program. I'm using, maybe an ORM. All I have to do is do select, start from the table, order by, and then I'll just simply do a fetch of the first 5 rows. Easy peasy. That is a really bad idea, and we're going to prove that. Let's do a demo. What was the demo? OC number 1? Yep. So here's my table called TX. I'll see if I can make this a little larger on our font. Might get, okay. Helps for people. Here's my table called TX. It's a big table. It's got 10 million rows. It occupies about 1.5 gigabytes of space. Now I'm going to use a view called $SQL work area histogram. It stores cumulative sorting operations for the entire instance. I'm the only person on this database, but because it's a running total, I need to capture its value before I do a query, run my query, capture its value afterwards, and then I can tell the delta to see how much work that query did. So I'll create my table called query before, which is a copy of that view. Now, let's do what I would call the proper method to actually get the first 10 rows. So my TX table is 1.5, it's 10 million rows, and I'm getting the top 10 using an inline view. It took 6.5 seconds. It had to work through all those rows. Let's look at actually how much memory was used. Now, the way we read this is it's like a histogram. So we can see that between 2K and 4K, we did 7 uses of that. So we needed 7 little blobs of 2K of memory, not a problem. We also needed 3 sets of somewhere between 1 and 2 megabytes of memory. Let's assume the worst, right, that it was 2 megabytes. So we used 6 megabytes of memory to do that query. That's pretty impressive because I scanned 1.5 gigs of data. Surely I had to sort all 1.5 gigs, but I didn't. The database is actually pretty smart when it comes to doing that. In fact, let's see if we can switch to another webcam. That one. So if you can maximize out your webcam again so you can see the piece of paper. Here I have a list of numbers on the left-hand side that I want to sort. If I want to sort that, this is how I would do it. and I don't want to use up too much memory. This is what Oracle does conceptually. Let's say I want the top 5 rows. Grab me the first 5 rows first and sort them. So it becomes 2, 5, 7, 11, and 12. So I had to use some memory to sort those first 5 rows if I want just the top 5. Then I read 8. Does that fit in the list? Yes, it does. It fits in here. So put the 8 there, put the 11 there, throw away the 12. Then I get 4. Does that fit in? Yes, it does. It fits in here. Throw away the 11. I get 16. Doesn't fit there. Ignore it. I get 6. Yes, it does belong in here. So throw away the 8, put the 6 in the top 5. I get 10, I ignore it. I get 9, I ignore it, and so on all the way down through the table. I did that initial sort of 5 rows, and the rest is just scanning through the table and throwing away or discarding rows if needed and inserting them if not. Let's put the right webcam back on. So you can see why we only had to use a couple of megabytes. Let's repeat that example now where someone said, I'm going to do it using an application. So I'm going to query all the rows and just, in this case, stop fetching when I get to 10 fetches. You can see for a start, it's running a bit longer than 6 seconds. It's still going. It's still going. It'll hopefully be there shortly. It took 3 times as long. When we look at the sorting information, because we never told the database we wanted the first 10 rows, we said, just do a query, order the rows, I'll determine which ones I fetched. Yes, I used 2 megabytes of memory. I also used somewhere between 1 and 2 gigabytes of memory. And in fact, I used so much memory, I couldn't do what's called an optimal use of the memory. I had to actually dump it to disk. That's what this delta 1 column says. I had to take one pass of information and dump it down to disk. So potentially 2 gigs of data was dumped to disk. Can you imagine if you've got 300 sessions or doing that? Servers don't have enough RAM to do that. It's a bad idea. So if you let the database know you only want to get the first 10 rows, for example, it's going to work a lot better. I'm just keeping it on the time. So this is how we do it, right? Inline view, it lets the database know to use these smart algorithms to not have to search through all the data. The way you can tell it in your execution plans is you'll see things like a stop key, which means I'm not going to sort all the data set, I'm going to sort the first n rows and then use a smarter algorithm. Or if you see things like window sort pushed rank in the execution plan. Pushed rank, stop key, they're the keywords that tell you I'm using a better and more intelligent sorting algorithm than just sorting the entire result set. You get other benefits as well. Let's go back to our demo again. Let's put an index on that column that we were sorting on, that query we ran. So put an index on my 10 million rows. Come on, little laptop, I know it's late. And now I rerun my query, get the top 10 rows using my good syntax. Instantaneous. Now that might think, how did it get the top 10 rows or instantaneously? Well, when we look at the execution plan, we can see what it did. It managed to use that index. It said, I can just walk backwards, effectively in a descending fashion, from the very largest value in that index, walk backwards 10 rows, and that's the top 10 rows. The index let me avoid a sort on that actually particular function. That's why it was instantaneous. What about if I said, well, I'm going to use it just the application doing my 10 fetches. So the application will issue just this query, ordered by object ID, and the application does the 10 fetches. The database won't do it. Because you never said I'm only getting 10 rows, the database is thinking there is no way known I'm going to walk backwards through 10 million rows, 1 row at a time in an index. It makes no sense. So you lose that optimization. People say, well, if I only get the first 10 rows, what about the next page? Well, let me stress to you, there is no next page. When you go to a Google search, for example, you see the first page. If you press next, which people rarely do, they normally do a new search, you're running a new query because that person may never come back and do a next page. It's a new query. And this is how you'll see in the documentation a way of saying how you should do it. It says I can offset 5 rows, I can skip the first 5 rows, and then get the next 5 rows. I know that syntax is there, and we made a big song and dance about it in 12C when it came in. I think you shouldn't use it. And I think it's a common mistake that people think that's a great idea. Bad idea. And even if they're using inline views to mimic this, I still think it's a bad idea. Forget the offset clause is what I'm saying. And here's why. Here's a simple example of the employee table, and I've already fetched the first 5 rows. You can see them there highlighted. So when someone hits page down, we're expecting that we would do something like this, right? Get the next 5 rows, all right? The problem is, what if during that time between the first page and the second page, someone inserts a new value? Well, you would see the wrong set of 5 rows, right? Because if we start a brand new query starting from the top of the table, if people are inserting new data, that distorts the result. And that's not what people want to see when they page down. In fact, I worked at a place once where you would page down through 20 rows on the screen, and on average, during that time, 20 rows would be added to the table. So every time you page down, you stayed on the same results every time, and it was obviously logged as a bug. What you really want to be doing is when you fetch that first page of rows, you need to remember the last value. So in this case, it was the 3rd of December, 1981, and that becomes an input into your next query to get the next page. So you never actually really want to be using the offset clause. You want to be using remember the last value and then query from there. Now you might be thinking an expensive query per every single page, that seems like madness. You might want to consider doing something like result caching. You can come up with a hybrid solution, which is, let's say on average, people page down 10 times and then just give up or run a new query. And I'm getting 10 rows per page. Well, what I might want to do is maybe get the first 200 rows in one query and send them the first 10. And then I want to hold those remaining 190 rows and farm them out. Now I could do that in the application tier, right? But that's quite a complex piece of coding to do. I could actually do something like this in the database. Go get the first 200 rows, and I'll use a common table expression. I'll call it with first 200 is the first 200 rows. And then you can see on lines 10, 11, and 12, I'm just going to get the first 10. And then I would go get the next 10, and so on. And in fact, that's going to work fine up until the first 200 rows or the first 20 pages. And then I would need to do a brand new query. But in this case, I'm doing one trip to the database to get 20 pages worth of rows. And hopefully my application is instrumented such that I'm recording over time what the average number of pages people go through is, and I can then feed that back into making adjustments to this code. What I can get some benefit doing if I do this all in the database tier is using a result cache hint to actually make that process very snappy. Let's look at a quick demo. So here's that same query with result caching. I'm going to run it. This is the first time I've run that query, so it's going to take a while to run because there's no result caching. It took me 4 seconds, and that got me the first 10 rows. Now I'm going to make the next 10 rows, but I've result cached that first 200 results. It's instantaneous. That's very good. In fact, until the TX table changes, that result cache holds valid. So you can see the execution plan. We have this, I used a result cache in there to actually get some benefit. And in fact, when I go to 21 and 30, once again, it's instantaneous as long as the TX table hasn't changed. So on data warehouses and paging through results, this is a great way of doing it. Result caching on the database tier can help you speed up pagination queries for those average number of pages that people look at. So how are we going for time? We're nearly out of time. So yes, I'll fly through this last one, and that'll be the last thing we'll do, and then we'll probably wrap it quits. I know I haven't really given a lot of time for questions because we're running out of time for now. I could obviously just talk over and over and over and over and just forever, but that's just me. I apologize. So what we'll do is you can always put your questions in the chat line now, and I'll look at them afterwards, or you can put them on Ask Tom, obviously, or you can reach out to me on Twitter, on my blog, etc. So I'll finish this one off, and then we'll wrap it up. Mistake number 5 is failing to rigorously test. In fact, a typical day when I used to be a consultant outside of Oracle was you get a phone call saying we implemented something, we imploded, please help us. And my response would always be, did you have similar problems in your test environment? And often the most common response is, test? What's the test environment? Or you get this one, it runs fine in test. Test, of course, is 20 megabytes, and our production database is 4 terabytes, etc. Or this one, we can't afford a full-size test database. Now, this is my most popular solution. This is the one I always recommend to developers and anyone, IT professionals alike, is if you're working in organizations that simply refuse to give you full-size test environments, give them this document as you're building code, right? And make them sign off. There's a very good chance that when we roll into production, this is all going to go absolutely pear-shaped. And if you're thinking, oh, I'll copy the optimizer stats from prod to test, that's never going to be good enough, right? Even if you're unlikely to get consistent plans, even if you copy the stats, because there are so many discrepancies now. The database optimizer gets smarter and smarter as time goes on. So things like SQL plan management, SQL plan directives, adaptive sampling, things like that. All these things get generated on a database by database basis. So often, no matter how much you try to copy those stats across, you still might not get consistent plans. And the explain plan can't tell you if something's going to run faster anyway. Here's a query against a product and a product sales table. The specifics doesn't really matter. Here are 2 potential execution plans. I would challenge anyone to tell me which one's going to run better. I might think the one with the lowest cost will run better because that's what the optimizer thinks. The optimizer is coming up with a plan that thinks, I think the nested loop, the top one's going to run better because it's got a lower cost. In reality, on this sample data, I actually cooked the books a bit. You can see I manufactured it such that the actually second one ran faster. And I could just as easily manipulate to run other way around. So you really need to run things genuinely as opposed to just hope the execution plans are going to work for you. And the reality is no excuses anymore. Now, obviously, it wouldn't be a presentation from an Oracle person unless they banged you with a cloud slide. But in all seriousness, this is an Oracle slide. I don't care which cloud you use, right? But cloud is one of the great benefits of actually saying, let's spool up a test instance that we can throw away very cheaply. The concept of, oh, we simply can't afford resources anymore, I think is gone with cloud. So it's an Oracle cloud slide, obviously, but I don't really care. Whatever cloud you use, don't use not having resources as an excuse. And I think we're just about out of time, so I'm going to get to wrapping up. I jumped to the wrong slide because we are just about out of time. Disasters are rarely deliberate, right? No one goes in and writes bad code really wanting to say, yep, I really want to write bad code. It just happens. But this is what I'm trying to convince us of doing today is measure twice, cut once is the hardware's cliche. When you're writing things, I know generally nowadays we're getting paid to code, not to think, but set that time aside before you write your code. How can I break this code? Test things, be brutal, see how much you can damage your code, right? See how many ways you can make it break, and then make it tougher as a result. Because we're all experts in hindsight. And one thing, the sole motivation for this particular code talk was it's important for us to all share the pain, even if you can't do it publicly, at least internally within your own teams, right? I'll give you a classic example. Many, many years ago, Amazon were down for 2 days. It was all over the media. And it was an Oracle problem they had. It turned out that someone had run a script that had accidentally updated the bootstrap dollar segment, which is the core boot up segment inside the database. They shouldn't have done it. You should never change the sys tables. But it was just an accidental script that ran. It wiped Amazon out for 2 days. And how do I know about this? Because they did a presentation about it. Something that almost destroyed their company, they went and spoke about it publicly. The DBA did a talk on it. So sharing the pain is important. It makes us all better as IT professionals. I'll leave you with this last slide, which is, hopefully, if you're on this call, you're obviously a member of the OD Tug, but more importantly, I hope you can get along to Kscope this year. It's in Florida in June. This is my plug. I won't be joining there. My speaker didn't make the cut. My speaker talks didn't make the cut. I got the nasty rejected email, but obviously so many good talks there. It's just one of those things that happens to a lot of us. So I won't be there, but I strongly suggest you go there. It's a fantastic conference. Do your best to get there, and that's about it. So I'll leave you this slide. Thank you very much for attending. If you're in my time zone, thanks for hanging around till 10 p.m. If you're anywhere else in the world, I hope you've had a fruitful and enjoyable hour. The slides and the recording will obviously be made available by ODTUG at a later date. But for the time being, please reach out to me on Twitter, subscribe to me on YouTube, reach me on the blog. But yeah, in particular, if you have any questions that obviously I didn't allow time for, my apologies, reach me on Twitter and I'll happily have a dialogue with you. And don't forget to follow me on Twitter and YouTube. Thank you, everybody, and I'll turn it back to Karen.
Thank you so much, Connor. Thank you, everybody, for attending today, and I hope everybody has a good rest of your day or night.